And this question is given that a satellite in a circular orbit very close to the surface of planet. At some point, it is given an impulse along its direction of motion, causing its velocity to increase n times. It now goes into an elliptical orbit with planet at the center of ellipse. Maximum possible value of n for this to occur is. Over here, if you are projecting an object from a particular height, and it is going to move in an elliptical path in such a way that the center of planet will be at the one of the focus, not at the center of ellipse. So this statement is somewhat wrong. We cannot say that it will be at the center of planet will be at the center of ellipse. It will be at the focus, any of the focus of that elliptical path. So let's see the situation. So assume that we are having a planet over here, and particle is projected from a particular height, let's say that is equal to h. Now if it is projected with a velocity that is equal to the exact value of orbital velocity at that point, then it can move in a circular path. It will move in a circular path of constant radius. But if you are projecting it with a velocity which is greater than that of its orbital velocity, then it will move in an elliptical path around the planet. So it will move in an elliptical path around the planet, let's say something like this, in such a way that this planet will be at the center of planet will be at the nearest focus. Or if you are projecting with a velocity less than that of orbital velocity, then it is going to move in an elliptical path something like this, in such a way that center of planet will be at the farthest focus. Now, if you are considering that if it is projected with a velocity which is equal to that of escape velocity, then it will move up to infinity. It will not be able to move in an elliptical path. So we can increase the value of velocity, but we should not increase the value of velocity more than escape velocity. So the escape velocity is nothing but, we know that it is root 2 times of orbital velocity. So the velocity that we increased should not be greater than that of escape velocity, or should not be more than that of root 2 times of orbital velocity. So maximum we can change its velocity to root 2 times of v naught, not more than that. If it is more than that, it's going to escape.